I hope you can hear me above the wind. So what I've been doing is experimenting with ways of improving conductivity through the rails, or connectivity. There's one way. These are rail clamps, not the over fish plate design, but I've managed to just get them over the fish plate, as somebody else has said in one of the forums. So you can just about use them as over fish plate, because you see there's still a fish plate in there, and so I'm using that to clamp and tighten up onto the fish plate. Not terribly satisfactory. There's a bit of a mess of soldering a wire across, and then another couple of pieces of wire soldered across there, across the joint. But the thing some of these are a bit messy. The thing I want to show you is the method I think I'm going to be preferring over here, and I'll explain why. So to do the solder joints, there's 3 or 4 stages to the operation. First of all, you've got to clean the track with a file or even a grinding wheel on the end of a mini tool. Then you've got to tin the track. You've got to tin your wire and shape your wire, and then you've got to heat it up and solder it on. And all of that, if you're used to normal sorts of soldering, sounds as though it might be fairly quick and efficient. But I found that I'm spending an awful lot of time trying to get the solder to flow onto the rail first, to tin it, and then getting it hot enough so you can get a good joint. Now, another alternative that I'm looking at is actually drilling through the fish plates and into the rail and attaching a piece of copper wire. Now, I've also thought of drilling outside the fish plates, where I would normally do the soldering, and attaching a piece of copper wire and screwing it on. Let me explain something that I read about before. There's crosshead screws, there's a prepared fish plate, because I've run out of screws. When looking at insulation displacement connectors, there was a description of it as being a gas-tight connector, and I thought, well, what does that mean? And what I read suggests that you have good mechanical connection between the screw thread and the rail, which gives you good conductivity. But the gas tightness means that if the thread cuts into, it's a self-tapping screw, into the rail, then it's such a tight mechanical connection you don't get any gas in there. And it's gases getting in the atmosphere which causes the corrosion, which causes the build-up of layer, which causes the problems in conductivity. Because what's wrong with a normal fish plate? Where's a normal fish plate? I've been messing about with all of these. What you get is when you pull this apart here, you'll find that you've got corrosion occurring between the rail and the fish plate, and it's that corrosion which is building up and forming a resistive layer, stopping the conductivity. And these fish plates expand and contract and open out. So if it was gas tight, you wouldn't get the corrosion in the first place. So that's fine between the screw and the rail, because it's a self-tapping screw into the hole drilled the right size. And these ones I've worked out are number 4 by 1/4 inch, these little screws. So what size screws? 3mm by 6mm. Okay, is about the right size screw. Number 4 by 1/4 inch pan head slotted head screws. Why am I deciding on slotted head screws? Well, on the rail clamps, a hex drive works quite nicely. But what I've found is that even with a very good number 1 posi drive screwdriver, and this is a number 1, look, just step back, it's only a small screw, self-tapping stainless steel screw, because you are tapping it into something else, you having to apply a bit of force, and it's very easy to damage the head or the end of the screwdriver, even with a good quality screwdriver. And these are reasonable quality screwdrivers, and one of the ones I was using was Posi. Slotted head in use, so it's the same person doing both things, that's me, are proving far more reliable. I'm able to exert greater force in the turning to get it to bind and cut its way into the rail. And there I'm hoping that there's enough, time will tell, enough surface area and a tight enough join so that that becomes, let's hope, gas tight, so we don't get a build-up of corrosion between the head of the screw and the copper piece there. But remember, the other thing I thought about was actually strapping a copper, and if I wanted to use 4 screws, 1 screw here, 1 screw through the fish plate, 1 screw there, 1 screw there, and a piece of copper wire running across all 4 screws. So on each side you've got 2 screws, and I think even that would be easier. Finally, to drill the hole, it's a 2mm hole. That thread is nominally 3mm, 2.9 on there. So it's so the hole is only just big enough for the root of the thread. So it's going to be tight, 2mm hole. I'll check the drill and I'll revise it. So drill a 1.5mm hole through first, because that drill that I've got 1.5 goes through nicely. Open it out to 2mm. Doesn't take too much then. If you've got a decent drill, I've got some rubbish drills, and then that's it. I think that's the whole thing. 2mm hole, number 4 by 1/4 inch, or 6mm long by 3mm nominal. You can get 2.5mm if you want to do metric ones. You'd have to play with it yourself to find out. Okay, that's it. Long term, we'll just have to see how those rail joints survive, which ones need more or less maintenance.